I'm just a bird among the trees, and today we're going to be studying aquaponics. Now, aquaponics is sort of a marriage of two different types of agriculture. You have aquaculture, which is raising fish, and you have hydroponics, which is the raising of plants using not soil, but nutrient-laden water. Now, the baseline principles between what makes aquaponics work is, to give you the short, sweet example, we have the fish down in the tank produce waste, and one component of their waste is ammonia. Ammonia is rich in nitrogen and is toxic to the fish. Their wastewater is cycled up into a grow bed. This contains not only your plants, but also two different types of bacteria. One type of bacteria breaks your ammonia down into nitrites. Nitrites are still a problem, plants can't use them, still toxic to the fish. But another type of bacteria can break nitrites down into nitrates. Nitrates are the processable form of nitrogen by plants and are basically non-toxic to your fish. The plants absorb the nitrates out of the water, and the purified water is cycled back down into the tank to relive the cycle over and over again. Now, what this project was for the ag class was an entire engineering process. The class was broken down into what ended up being 3 different engineering teams. Each team was responsible for designing their setup, as in blueprinting, then figuring out what sort of materials they needed to construct it on a $30 budget. Sounds like a lot, but not when you think about all the components that are needed to make this work. They then had to A, acquire those materials, and then B, build these functional setups with those materials. Once they had a functional setup constructed, they had to conduct a 50-day trial in which we are determining which setup is most effective, with the end goal being we will implement this large scale in the greenhouse, whichever one is most effective, with the first scale up being the goldfish pond right on the other side of this table. But first, we gotta figure out what we're doing and build these things.
Okay. Yes, my brother. Nope. We don't want it to leak because I don't have a chance to kill our fish. It's not. It's like Renaissance rare. How do we use this? Starbucks, I have glue at my house that specializes in it. Yes, just there. It's not liquid pressure.
This is ag class. Thank you very much.
I feel like maybe we should try and get it as close as possible. Where do we actually use it? Oh, a lot more. Okay.
Think about it. Maybe more than nearly gets around the inside. Yeah. Okay. Well, as long as we keep it safe, we should Starbucks. Or alternatively, we could would just find some way to just like put something.
What up?
Yeah. The problem is that it's rounded. There's no way to go down.
Yeah, so it should go over this.
I want to just test it with some water. Let's go put it in the sink and see what happens.
Oh, hi. You could use scissors.
Why are you watching me cut this ineffectually?
Not necessarily evenly spaced because we still have to account for that.
Yeah. Why when the camera turns on, I ineffectual.
Because your two cents is beautiful.
Okay.
Okay.
Thank you. So like here.
Now let's put it in.
Perfect. Perfect. All those fishies. Yum yum yum.
Yes, we can do that.
Extendable length.
Yeah.
I don't know.
You're gonna kill your plants. This is PVC.
This one way
That's
walk.
glue. This is dry PVC. Yeah.
Now a walk. Drinking water.
They say it's not.
Yeah.
The government is lying to us.
Birds don't exist.
If anything, it's closed our
I really don't think so.
Okay. Yes. The pellet should be floating, right?
See how you have very significant cooling in there? You might have trouble with root rot.
Is that for the light?
No, I think that's just the fish tank. Not the fish tank, the fish pond. So,
That was the water.
lower it a little bit. Maybe we can go to the back end and just get a walk a little bit smaller. You knocked the plants over.
Oh my goodness, the Laguna has started to sprout. And the lettuce is just beginning.
Okay, so how this system is supposed to work is we have the fish on the bottom. They're going to do whatever they do, let out their waste products. Mainly what we're looking for is ammonia. We're going to filter it through here to get out the solids. Once the solids are out, the ammonia will still go through. These little bits of grow medium and pellets. The pellets can keep the grow medium stable in the water. Water will go around. The absorption to these where the seeds are. Seeds will start sprouting. But first, the ammonia has to be broken down. The pellets are here so that the bacteria have more space to start growing on. The bacteria will break down the ammonia into nitrites. The nitrites broken down to nitrates. The nitrates can be used by plants. It's the consumable form of nitrogen that plants can use. They'll use those to sprout, and then the water will come back out here. Hopefully the ammonia will have been removed that way, so we infect the fish. Projections that I see that, as you can see, this one's a beauty. And possibly the fact that since our tank is higher, since our filter is higher than a lot of other people's, we might have a problem with the fact that ours might need an extension. The pump might not be strong enough to pump from a lower thing all the way up. And so currently those are flakes and waste most likely at the bottom. They'll have to be stirred up or vacuumed out.
This is our aquaponics tank, and as you can see, we have stuff in our clay pellets or grow medium. Yeah.
have fish living there peacefully, and then that's our air pump going through. And then we also have a filter here to filter out the water so nothing bad happens. But how the system works is how that the fish poop out pneumonia, and then pneumonia goes up to the air bubbles, and it will help get the growth bed mule up to the cup. And since the little pellets have bacteria in them, that the bacteria will break down into nitrites, and since it's still kind of bad for the fish and the plants, that the other bacteria breaks down into having nitrates, and that'll be good for the plants.
Alright, so I also built an aquaponics setup as the fourth and final engineering team for this project. My setup has the most guppies. I haven't actually counted them because since I've given the students some, there's a few. The water is taken into a two-step pump setup, seeing as my grow bed was actually higher than the head that either pump was able to pull, so I made this two-step pump system with a vase. This pump pumps into the vase. The vase is also acting as a settling tank for any solids to keep solids from ending up in the grow bed. Water is pumped from the vase, which is at a higher level than the tank, through this pump and into the grow bed. The grow bed is just a bin that I found. Drilled a hole in the bottom of it so that I could fit, this is a bell siphon. The bell siphon will cycle the water through the grow bed so the water level raises and lowers cyclically. I have two species of plants here. This is Mizuna, and then I have a variety of lettuce that I cannot recall at the moment. Water then passes back down into the grow bed. So, key thing to making this work is the nitrogen cycle. We have ammonia from the fish's waste is brought up into the grow bed. The grow bed allows bacteria to grow two different species we're interested in. One processes the ammonia into nitrites, and then another processes the nitrites into nitrates. The nitrates are able to be utilized by the plants, so this whole setup is acting as a big old biofilter, which allows me to have the fish at slightly higher density than would be ideal for the area of the tank. I also have this device on the side, which is an auto feeder, which allows me to give twice a day these guys a very consistent quantity of food. Problems I foresee? I've already foreseen that this grow bed actually results in a highly increased evaporation rate. I think if I add another layer of clay pellets over the top so that there's actually a layer of dry medium, I didn't foresee, you can actually see I can dig down a ways and there's no water, but it does percolate up very readily. So I'm going to add some more layers. Mizuna is sprouting very, very quickly. I planted these quite literally 3 days ago, and it's already sprouted. So that's good. Other thing that I foresee being a problem, these are just balanced on a couple of janky little pieces. The reason I've got this off-center is that the flow rate of this pump is greater than the flow rate of this bell siphon, so that's a little bit of a design flaw on my part, so I've just got this off-center, but because it's just balanced, it's not fixed in place. That might lead to a problem later. But other than that, this is working very well, and I don't
There's not much ongoing care that I need to give the setup due to this here. The guppies are all very healthy. I do have one in here who has scoliosis, but that's a genetic disorder, not any sort of disease that I need to worry about. But these guys are all looking very beautiful. Happy guppies. And the bell siphon is acting as a wonderful bubbler. Yeah, that's my setup. Woohoo! Alright, I know this looks terrible, everybody, but a couple of these guppies look pregnant, and guppies are known for, shall we say, consuming available babies. So I didn't want to put in any plants that are going to use up the nitrates that the system is producing. I want those to be used up by the lettuce. So I put in some simulated weeds for the babies to hide in. Should be good.
Keep out of the reach of children. Dang.
Okay,
I'm not going to drink it.
How many drops for this?
it says on the things.
Oh, add 8.
That's a low pH. This is high range pH.
Okay. So put it in.
2 drops?
Test for pH first. If it goes higher,
How do I unlock it? Oh.
if it
It's a
turns-
child lock,
Yes,
dude.
I
Come
know
on.
Starbucks, okay?
How old are you?
Okay, yes. So in
Blue.
this case, we're
Blue.
adding
Why we blue?
8 of one
I think
and
it's
8
this one.
of the other.
Yeah, we're gonna have to redo the pH.
It looks like 7.6 to me.
Yeah, 7 point.
No, we're gonna have to redo it because it might be higher.
People can't do that?
No, we're doing the high pH range.
Okay, so my ammonia is around 0.5. So ammonia. Wow, no.
It's a child lock.
Okay, to the next one, please.
Good job.
Do you need help?
No.
Okay.
Add 5.
You're adding 5?
It says to add 5.
Okay.
2, 3, 4, 5. Oh, this is it.
Okay, remember
Here, put the cap on.
it. Don't do anything until you cap it.
Okay.
Give him the cap.
Just a little. Okay. And then.
Make sure it caps on tight.
Alright.
It's as purple.
Whoa!
Beautiful purple.
But that?
Whoa! Whoa!
No,
Whoa! Whoa!
High.
That means you have very high pH.
What does that mean?
That means it's too alkaline.
It's too alkaline,
Too
which
alcohol.
means it's very basic. 8, 9, 10.
That's
Yay,
both that-
counting and stuff.
I'm surprised Dylan can count to 10.
Alright, give it a good shake.
Oh, I'm surprised it has 0.
That looks like 0.
Yeah.
So, interesting.
How does that happen?
Well, that means that the nitrate, because I took a sample from the tank, that means that there's no nitrates making it back to the tank. We can see that there's nitrates in the water, period, because the plants are growing very well. So that means that the system is actually well balanced. Yes, 8.4 was what mine was.
Should we write that our pH?
Yeah, right, your pH is 8.4.
And then should we do all the rest?
Yeah, go ahead and do the rest of these, and you have to, Nathan, you're recording? Goody gumdrops.
I need to drink some acidic water because my stomach acid is at a 15.
Why don't you just drink some lemon juice?
They put 7 centimeters. And then there's like a second one.
Nathan, just right between 0 to 0.05 for pneumonia.
Probably does affect the
Yeah, probably has.
Nitrate also zero.
Ammonia 0.25.
Nitrite is 1, nitrate.
Yeah, oh, wait, and see if it's 5 foot. That way we can like. So you want just the high pH?
If it tests really high, then you only need to test the high pH. If it shows like down at the lowest level, then you can test the lower pH. So what is our...
8 between 8.4 and 8.8.
Yeah, so that's a circumstance you don't have to test for lower pH. Before we wrap up this video, I've got a couple big shout outs of thanks that I want to give. First off to Shauna, who donated the guppies that we used in this experiment. These guys are beautiful, adorable little creatures that are an absolute treat to watch, and I love them so much, and they turned out to be absolutely perfect for this experiment, so thank you so much. And then second, I wanted to thank Anna. Anna donated the Aquaponics testing kit, which gave us a very precise measure of all of the water chemistry that was going on in our setups. It was amazing. So thank you guys so much. And then I want to thank everybody who's in the community who took interest in this project. Had a lot of people come in and being quote-unquote nosy to see what's going on, and I loved it so much, all the support that you guys gave. And in addition to all that, our little online community, this channel, has expanded to over 100 people, and there's been so much support from everyone in this little YouTube community. So thank you so much. So I would name this experiment entirely a success. All the guppies are healthy, all the plants are growing, and all of the setups, everything is sort of beautiful. But this is not the end goal of this experiment. This experiment is a small-scale iteration of the end goal. We are doing this experiment to determine which setup is most effective, and that setup we will be implementing large-scale in the greenhouse. So specifically, over in the corner, you've probably seen in all the other videos, there is a goldfish pond. Excuse me. There is a goldfish pond. And you'll also notice that in here, there's something else. We're growing mushrooms. So that was what was going on in the background of a few of the other clips in this video. We are growing mushrooms right now. Yet another experiment. But I will be seeing you in that next video. Bye! Bitty baby guppy. Little tiny bitty baby guppy. Bitty bitty baby guppy. What's this?